Hi, welcome to your lesson on expected values for probability distributions. Let's start with this opening problem. We have the probability distribution of a discrete random variable u is defined by this function. As you remember from the last lesson, you can use a function to produce all the possible probabilities that a random variable can take. So in this case, we are told that u is an element of this set. So you can only use these four discrete values, plug them in here, and those will then generate four probabilities, one for each of these. So create that table of probabilities, and this table at first will have the letter k for every probability value. Okay, here's the table you should have generated. Using those four u values, so these are the four possible things that can happen. Imagine this was like the coffee maker example. Let's say we had 4 coffee makers that can break 5, 6, 7. So these are the 4 things that can happen, and here are the probabilities that were given to us by this function. So now that you have this table, using what you know about these probabilities, what do those have to equal? Remember that? So using that, let's see if you can solve for k. Okay, as you may remember, if these are all the possible possibilities and these are the probabilities, then these 4 probabilities for all the possibilities must add up to 1. So you set those equal to 1. See how we added those up? They make 20k, set it equal to 1, and then you solve by dividing by 20 and you get that k is equal to 1 over 20. So that idea of these adding to 1 is important here. So now we know that. Now that we know that, we can now replace these probabilities with actual probability values. So do that now. Rewrite this table, getting rid of the k. Okay, this is the table you should now have. When you put a 1 over 20 in here, you end up with 4 over 20, which reduces to 1/5. Follow that along here, and you get these values. So now we have a proper probability distribution table. And so the probability of 4 occurring, it doesn't tell us what the situation is here, but we know the probability of 4 occurring is 1/5, and 5 occurring is 3/10, and so on. Okay, try question B. For B, if you run 100 trials, or if you run this experiment 100 times, what's the expected value? And I'll let you know that expected value basically means what do you expect to happen? What's the outcome you expect to happen for each possible outcome? So you know the probability now of a 4 happening, or a 5 happening, or a 6 happening. So now if you ran an experiment 100 times, how many of those 100 would be a 4, how many would be a 5, and so on. Okay, the way to calculate that is basically to take each value, the probability of each value, and then multiply by the number of trials. So we knew, let me go back to this number, the probability of a 4 occurring is 1/5. That means 1/5 of these 100 experiments will produce a 4. So 1/5 times 100. And that work is here, 1/5 times 100. That tells you that 120 of the 100 will be expected to be a 4. You can continue that process for these. A 5, for example, had a probability of 3/10. So you do 3/10 times 100, because 3 out of 10 out of the 100 will be a 5, and that should produce the number 6, and then 7, 30, and 30, 20. Okay, so these are the answers that you should expect from this one. So 5, 6, okay, sorry, 30, 20, 30, 30. I think I said the wrong one a moment ago. It should be 30, 30, 20 are the remaining ones, and the first one was 20. Okay, so check your work, and let's move on to the next one. So we have C. This one, it says find the values of U found in these 100 trials, assuming the frequencies of each outcome are given by the expected values in B. So how do you find the mean? Now you have all the outcomes that happened, so find the mean. So again, here's our table of expected values, right? A 4 is expected to happen 20 times, a 5 30 times, a 6 30 times, and a 7 20 times. So basically, this is like a frequency table. And when we did mean for something like that, we basically have to add up those values and divide by 100. But we don't just say 20 occurs once, right? A 4 occurs 20 times, so you do 20 times 4. There's basically, that means there's 24s occurring, and a 5 occurs 30 times, so you multiply that, and a 6 occurs 30 times as well, and so on. You multiply all those, divide by 100, and it tells you what the mean should be. And interpret your answer. Well, let's look at it together. Basically, yes, of course, in this, whatever the situation is, the possible outcomes are 4, 5, 6, or 7. So how can we have a mean of 5.5? Well, the mean doesn't actually have to be one of the possible outcomes. The mean is just a value that it's expected to happen, but might not happen in real life, because in this case, it can't be 5.5. But 5.5 is directly in the middle of this data set, and since this is all symmetrical, you can see, then 5.5 makes sense that the mean is right in the middle. Okay, so big idea. So drawing from what we just did with that question, we're going to do some big conclusions and get an important formula. So this is a key concept. It's called expected value. So we had that table of expected values. We knew that 4 is expected to happen 20 times, that 5 is expected to happen 30, and so on. And then from that table, we found the mean. And we found the mean again by 4 times 20 plus 30 times 50 plus 30 times 6, and so on, right? That's how we found the mean. We found the mean. But another way to write the mean, look at this. If you have this multiplication here, you can actually write it this way. You can say 4 times 20 over 100 plus 5 times 30 over 100. You're just breaking this up into separate fractions, or plus 6 times 30 over 100 plus 7 times 20 over 100. That means the same thing as this. Now that we've broken it up this way, we can go a step further. We can reduce this 20 over 100 to 1/5, this into 3/5, this into 3/5, and this into 1/5. Now if you look at this closely, it should look familiar, because basically these values here are the ones we had from our original probability distribution table. So we had our expected values here in 100 trials, but here we have our original probability table, and notice that those values there are the probabilities. So that tells us when we're looking for a mean or expected value, which we found earlier, we can just begin with our probability table and do this multiplication instead. So we don't have to find those values and then it takes the mean. We can just begin with this table. So what that tells us is we can just take your value and multiply by the probability, plus next value times the probability, plus next value probability. And that's shown in this, what's called the expected value, or basically that is a mean, the mean formula, which it's all written here, but what it means is, so the expected value is equal to, this symbol means mean, so again, expected value is mean, and then we do that by doing the sum. This symbol means sum. The sum of these multiplications. So this is the value, and this is the probability of the value. So again, it's 4 has a probability of 1/5 to occur, so we multiply that, and that's what this is showing here. Multiply the 4 by 1/5. Sum means then you do it again for the next value, 5 times this probability. And then again, with the sum, we continue until we've done all 4 of them. So that's the formula, important one, key formula. Let's try it on this problem here. So read this problem and then see if you can find the expected number. So using that formula for expected value, we can say it is the sum of s times the probability of s occurring. And in this case, we have 2 has this probability of occurring, so you multiply those, plus 3 has this chance of occurring, multiply those, and so on and so on. Add them up, you get this one here. So on average, the newspaper agent should expect to sell more than 3 newspapers, although of course 3 is the most likely outcome we can see here, but on average they'll sell more. Again, it's a decimal value. Obviously they're not going to sell 3.83 newspapers, but what that number tells us is that it's going to be, they're going to sell sometimes 3, sometimes they're going to sell all these numbers sometime, but in general they'll on average will sell about close to 4, more than 3 newspapers. All right, great job. You are ready for our homework practice. If you want to get a head start on the practice assignment, go ahead and do it. But like I said, we're going to switch up and watch videos at home and do homework in class together. So see you soon.